It's time for another math easy solution to discuss, well, the derivative of basically arccotangent of x or inverse cotangent of x. Basically using implicit differentiation. This is just part of a series that I've done on inverse trigonometric functions. Some random guy asked me to do one on these and I'm like, might as well. Okay, so let's just write down the function here. Y equals inverse cotangent of x. So this is also the cotangent, and recall from what inverse means. In my other video, you can see the video links below on just basically all videos that relate to this. Basically, the inverse function, this just means x is equal to cotangent of y. So all you're doing is finding the inverse or the opposite. So instead of finding what, instead of finding the actual value, now we're finding whatever is inside here, which is inside this cotangent one. And also recall that cotangent, the definition of cotangent of, let's say y, this one is just equal to 1 over tan y, and tan y is equal to, this one is just sine over cos, so then this is just going to be cosine of y over sine of y here. And now the first thing to do, actually just we want to graph this out, because I remember when you have to do derivatives or graph of the inverse, you have to make sure that you're getting the correct domain. You can see my other video on inverse trigonometric functions. I'll show you what I mean by this. So basically for cotangent of y, well, let's just graph it in terms of x. A cotangent of x here, this equals this one here. So at, let's say, x is equal to 0 here, we know that sine is going to be 0. So sine of 0 is equal to 0, and then cos of 0 is equal to 1 here. And then so you're going to have, in this case, a 1 divided by 0. 1 divided by 0. So it goes to infinity. So it goes to infinity like this, positive way, and then when you look at pi over 2, so at x is equal to pi over 2, we get this one here, cos is going to be 0 now, cos pi over 2 is equal to 0, and then sine of pi over 2, is just equal to 1 here. You can see the video links below on trigonometry, on sine and cosine, etc. So basically now we're going to have a 0 over 1, so this is just going to go down to 0 here. So it's going to go down all the way closer to 0. And then, in this case as well, you're going to have something, then when you look at pi here, you're going to have, something like this here. So cosine of pi is -1, and then sine of pi is 0. So it's going to approach, again, 1 over 0, but now it's going to be at the negative side. So you're going to have something like this, and it keeps going down, etc. And then since it's a trigonometric function here, it's periodic around that. So this is actually going to be something like this everywhere here. So you're going to have it something like this here, so it goes to negative pi and etc, and then goes to infinity at near 0 here. So it looks something like this, and it repeats forever. Yeah, so if I graph it with Google here, this one is just cotangent of x here, so it's going to be the same thing here. So this one you have to write cotangent, doesn't work if you just write cotan for some reason. So basically, so you have it exactly like how I graphed here, so it just repeats forever. So now when we look at the inverse of this function, if this one is, we'll just call this cotangent of x. So if you want to find the inverse, well, we need to pick a domain here, because the reason is when you take the inverse of something like this, this usually gets flipped. So then you have to recall from the horizontal line test. So I showed in my earlier video. So you basically have to you basically kind of draw a line here. So then so you basically have to draw a horizontal line, and only where it selects at one point, you're going to pick that domain. So in this case, what's usually picked as a domain is just usually from here to here. So usually from 0 to pi here. I'll explain further on this horizontal line in a bit. But basically, so this is the usual domain. We'll just write that down. Actually, not the domain, the usual range for cotangent of x, because we're going to flip it around. Remember, in my other video, I showed that the inverse is just going to be a flip image across this y equals x line. You can see the proof for that in another video. So basically, at this point here, we're just going to switch up all the values here. So at this point here, this goes to basically at pi and to negative infinity. Now we're going to switch this into negative infinity to pi. See, I'll draw this in red for the inverse here. So now we're going to have, at this point, it's going towards negative infinity and pi, because that's all we do. We just switch up the values. So at this point, this one is going to be, well, pi over 2 and 0. So now we're going to switch it up into this point here. This is going to be 0 and pi over 2. There's pi over 2 here. And now at this point here, this one is going towards 0 and infinity. So now we're going to switch it up to infinity and 0. So I'll just draw this over like that. So this is going to be, well, infinity and 0 here. So then it's going to look something like this. So the graph of it is going to be something like this, and then it goes all the way into infinity here. Just connect it there. Yeah, so the reason we're picking only this curve here, because if we pick these ones will be on top, and then for every, let's say, yeah, for every x value, you will have multiple values. That's why you only pick one line. Using the horizontal line test, only make sure it goes through one of them. So we pick this point here. And also, if you want to look at the curve here, this is our cotangent of x. So if you graph that, and it looks exactly like we had here. So this is pi over 2, or around 1.57, and it goes to infinity at around pi, which is around 3.14 when you go infinity. And this one, it goes to 0. So see, yeah, it looks just like that. And so now that I've gotten through this and we found the range, and the domain is all real numbers, now we could graph it. Basically, I just wanted to illustrate how it looked first. So now let's just go back to the curve, or the equation. Yeah, so we write this back down. Y is in cotangent inverse of x. And then so we just switch up the variables and to get rid of this. This is all that it means. X equals cotangent y. And then this just equals to 1 over tan y by definition. And now, so we have this. So let's just simplify this further, or just write down the tan on the other side. So we're going to have tan y equals to 1. So just multiply the tan out. So now we could use implicit differentiation, just do derivative and then using chain rule here. So this one here, we take derivative of this is going to be, well, 1 derivative of x times it by tan y. Just recalling our chain rule and product rule. And then this one's going to be plus x times it by, the derivative of tan y is just going to be secant squared y, and then times it by, this is just going to be now y prime using chain rule, and then the derivative of 1 is going to be 0. And then just recall, in this case we're just doing dy over dx, or derivative in terms of x here, so that's why this is going to be 0. But anyways, so now we have this. Let's just simplify this in terms of y prime, or the derivative. This is equal to, now if we simplify this, then just take this on the right side, tan y over x secant squared y. Yeah, so we have this function here, and to recall from this one here, we could write tan y in terms of x here, because we have x is equal to 1 over tan y from above. That's just from this one right here. So then this is going to be now, if we write tan y by itself, tan y, just flip it over there, equals to 1 over x. Yeah, so we have this factor, and also we can simplify x secant squared in terms of tan y. So if you recall this identity here, cosine squared y plus sine squared y equals 1. And then if you just divide this out by cosine squared y, and this one also, just divide everything by cos squared y. Yeah, and then we'll just get this one here. So if we just simplify it out, we're going to be 1 plus tan squared y equals secant squared y. So we could plug this in there. So let's just plug this and this inside the function here. So we're going to get, yeah, so we'll get this one here, 1 divided by x squared, then this 1 plus tan squared y. That's because there's an x already there. And then this going to be 1 over x and multiplies by the x squared. So now this one, we could simplify this further by just throwing this back in there, because this tan y is equal to 1 over x. So then tan squared y is going to be 1 over x squared. So this is going to equal to now 1 over x squared times it by 1 plus was all divided by. This is going to be 1 over x squared. Now if we simplify this out, just multiply the x squared, we're going to get now 1. This is going to be x squared plus 1 here. This x squared is cancelled. So we're going to have this. This is actually our answer. Yeah, and thus this is, if we write it down, the inverse of cotangent x. The derivative is going to be just negative 1 over x squared plus 1. So this is the derivative. Well, that's all for, hopefully you learned about this one here. It's a pretty extensive video on this. Hopefully you learned about the graphing, and just make sure you understand the inverse idea. All you do, inverse is just switching the x and y's. That's all it is. You're solving for the x now instead of the y. And also this whole graphing of the inverse. Remember, you only select one. You only select one area here. You can't select these two, because you're gonna have, then when you inverse it, you're gonna have one x value and two y values. But because in this case, you're gonna have one y value for multiple x values, and they're going to be switched, so you can't have it like that. It has to be a one-to-one function. Just recall in the video links below. But that's all for today. Hopefully you learned, and yeah, you can download these notes in the Dropbox link below, and stay tuned for another math easy solution.